Hey, Myers Mathematics, Kyle here. Let's just jump right into it. So, how to use the chain rule? Well, the first thing I should probably say about this chain rule, one is that it has to do with derivatives, right, of a function. Um, and then the other thing is that really every time you take a derivative, you're kind of doing chain rule. It kind of just happens all the time. It's just that normally the chain rule gives you one, and so you don't have to worry about it. So for instance, if I take the derivative of sine, right, sine x. So let's say derivative of sine, right? So if you're familiar with your trig derivatives, it's going to be cosine. But since sine has an inside function, x, I have to take the derivative of that function. So the derivative of x is 1, and that is a chain rule. Now, it's, a pretty easy chain rule because I actually could have just forgotten to use chain rule and I would have gotten the same answer, right? Because anything times 1 is that thing. Um, but what if it wasn't sine x? What if it was sine 2x? Well, now you do the same thing. You just take the derivative of the sine of the function. The fact that there's a 2x there does not matter when you take the first derivative, right? Because now there's a chain of derivatives. So I take the derivative of sine. Derivative of sine is cosine of the function. Then I take the derivative of the inside function, which is 2, right? Derivative of 2x is 2. Okay, so that's how chain rule works. It's a chain of derivatives. Okay, so let's look at another example. What if it was d dx? We already know what e to the x is. And if you don't, I'm about to tell you, it's e to the x. It's the easiest. It's literally the easiest derivative because the derivative is itself. So e to the x derivative is e to the x. But what if, right, because technically there's an inside function. The inside function is x. So I take the derivative of x and I get 1. Okay. Now, what if I take, and let's use a different color. Let's say I want to take the derivative of e to the 2x power. And they normally don't have parentheses around it, but I'm going to put parentheses so you can see the chain rule in action here. So the derivative of e to the 2x, well, it's not going to be e to the x, it's going to be e to the 2x. The fact that you're going to take the derivative of the inside function eventually doesn't mean you do it right away. You actually ignore the fact that there's extra stuff when you take the derivative. You just take the derivative as if there were nothing there. No extra stuff, that is. But then we take the derivative of the inside function, which is the 2x. Derivative of 2x is 2. And so there we go. So it's 2 times e to the 2x. And if you were to take the derivative, again, then it would be 4 e to the 2x, right? And then 8, and then 16, and right, it would double each time. So what about regular functions? Let's just say we have f of x equals x squared plus 2x plus 1. And then let's, maybe take all of this and square it. So that way we have a chain rule. Well, actually, you know what? Let's not do that just yet. So this will be the last example, but I'm going to kind of make it into 2 parts. So the derivative, right, f prime of x would just be 2x plus 2, and then the 1 would go to 0, right? Just goes away. Now, let's make the function a little different. So let's say instead we do x squared plus 2x plus 1 squared. And I want to take the derivative. So now what we do is now this whole thing, this whole x squared plus 2x plus 1 thing, it's all, excuse me, it's on my alarm. Oh, it's only 8:30. I have random alarms. So if we have x squared plus 2x plus 1 quantity squared, I'm going to take the 2 out front, as if this were all like x squared, right? Because if I take the derivative of x, let's say this is, let's do it like a u substitution here, right? If this was all a u substitution, then it would be 2u to the first power. So this is going to be the same exact thing. It's just going to be 2, and then I ignore the fact that there's a bunch of extra stuff, x squared plus 2x plus 1, and then I decrease the power by 1. But now this whole thing, x squared plus 2x plus 1, is my inside function. So I multiply by my inside function, and of course 2x plus 2 is what I get when I multiply by the inside function. And now I'm done. So you could technically keep going here, but I don't know. I guess we'll go ahead and clean it up a little bit. You can actually take out a 2 here. There's an extra factor of 2 that I can bring out. Right, so that 2 just comes down. This 2 came from taking out the factor of 2 from here. So I'm going to just kind of do this. I don't want to confuse you too much with the algebra here, but basically this would factor, so I'd get 4 plus x, 4 times x plus 1 cubed is what I would end up altogether. But usually when you're doing derivatives, it doesn't clean up this nicely, and you don't normally need to clean it up as far as you possibly can. That's usually just if your instructor really likes to have it cleaned up really nicely. And if he or she does, I'm so sorry. Because it's more about the calculus, it's more about taking the derivatives than it is about, do you have the algebra skills to clean it up afterwards. So yeah, that's how you use the chain rule, and there's no limit to how many times you can do the chain rule. So actually, you know what? Let me say a couple more things about this. So there's a couple different functions in which you'll use the chain rule. So here's a couple things to look out for. Trig functions, right? So for example, sine of x. Then you have power functions. So what I mean by that is like e to the x or a to the x. It's just, 2 to the x, right? Stuff like that. And I didn't actually show you how to take the derivative of that. It's a little bit different than e to the x, but I'll save that for another day. Then you have log functions, right? Logarithmic functions. So for example, just log base 2 of x, things like that. And then what was the other one? Powers, logs, roots. Yeah, roots. So like the square root of x or the cube root of x squared, right? Something like that. So all of those things, if you combine them, you can make it so that you have a chain of a chain of a chain. So let's look at one example, and this is what you do with what I just showed you. You look for those things, and however many of those things are in a function, that's typically however many times you're going to have to take the chain rule. So here's the example. Let's say we have e to the sine of 2x. E to the power of sine of 2x. Okay, so the function itself is whatever the biggest thing is. It's e. So the derivative of e to the x is e to the x. So that's it for the first part, is e to the sine of 2x. Derivative of e to the x is e to the x, so it's just that. Now we get into the inside area, right? So here's the inside function of e to the x. This is the inside, all of that. So I take the derivative of sine. Well, the derivative of sine is cosine. Cosine 2x, right? But I have one more because there's an inside to that, and it's right here. So I take the derivative of the inside again. Derivative of 2x is 2, and now I'm completely done because I've got my inside function was just 2x. Took the derivative of 2x and I get 2. Now, the reason why you know you should stop is because you don't have anything else listed like what I have listed over here: trigs, powers, logs, roots, nothing else like that. If I were to take the derivative of 2, I'd get 0, right? So if I multiplied by 0, the whole thing would just be 0, right? So that should definitely be a red flag. If you take the derivative and you get 0, you went too far. You took the chain one too many times. Or if you get 1, because 1 is unnecessary, right? So if you get a derivative of 1 or 0, then you went too far. That was it. Go back a step, clear out your 1 or your 0, and that's your answer, okay? We can clean this up just a little bit. I'll put the 2 first. And I don't know if I want to put them in reverse order or not. I think I'll do 2e to the sine of 2x times cosine of 2x. I don't know. That's about as clean as I can make it look, I suppose. But that's chain rule and chain rule of a chain rule. Now, again, there's no limit to how many times you can have a chain rule, but typically they'll only have maybe 2 or 3 at most different types of chains, and you'll be able to figure out how many times you'll have to take the chain rule based on how many of these things you see. And of course, in our example, we had a sine of 2x, and so since there was a function that wasn't just an x inside of there, we had to take the derivative twice for the chain rule, 2 chains. All right, so this has been Myers Mathematics, and of course, I have a guide on my website, Myers Mathematics. You should go check it out. It will help you solve just math problems in general. It's a guide to help you to never miss a math problem. It's the 5 mistakes that everyone makes and how to avoid them. So go check that out. It's on my website, Myers Mathematics. I hope that is helpful for you, and I hope this video has been helpful for you. If so, give it a like, and I'll see you again.